If you're not using the theory attributes InlineData, MemberData or ClassData, you aren't taking full advantage of xUnit's capabilities. Stick around as I'll show you how to use them and when to use them. We're going to be writing xUnit tests for these methods. One of them converts the speed from miles per hour to kilometers per hour, and the other does the opposite. Now traditionally, if you're writing an xUnit test, you mark it with the fact attribute, and that means that this method is a unit test. Now the problem with this is that you're limited to one data set. This is where theory comes in. You can use it for parameterized tests by supplying multiple data sets using parameters for the same test method, and a number of ways you can use it. We've got this unit test, we've marked it with the theory attribute, we're passing in some parameters in, but we need to supply data for those parameters. The way we do that is we use the InlineData attribute and we can supply some values for it. So for miles per hour, we can add 100 and we'd expect the kilometers an hour to be 160.93. We can also add multiple InlineData attributes to the same unit test. So we could do another test of 50 and we expect the kilometers per hour to be 80.465. So now in the first instance, 100 miles per hour would be 160.93 kilometers per hour. We'd use these parameters within the test method, and then we can use it to do our unit test. This translates to two separate unit tests within the same test method. One of them where we're testing 100 miles per hour and the other one at 50 miles per hour. Running the test, they both pass. We can also do the same when converting kilometers per hour to miles per hour. So here's our test. We're passing in kilometers per hour and we're passing in the expected miles per hour. We call the InlineData attribute and we expect 321.86 kilometers per hour to be 200 miles per hour. We can then add another test in there. We expect 241.395 kilometers an hour to be 150 miles per hour. This now means that we've got 4 unit tests ready to run with the data coming from the InlineData attributes, and they've all passed. Just to note that you must supply the same number of parameters in the InlineData attribute and the test method. If you don't, you get this exception saying InlineData values must match the number of method parameters. Using InlineData is good for small and simple data sets, but it can't be used for any sort of calculation, nor can it be used in other test methods. It can also get very bloated if it's used too often. Another way is to use the MemberData attribute where you supply the data in a property, method or a field. Before we look at that, just a reminder that when you subscribe to the channel, you'll be notified for any new .NET videos that are released on this channel. We're going to supply the data for our unit test in this field. So we're returning a list object array where each object represents a parameter in our unit test and each list represents a new unit test. So we're going to be using it for this unit test here. We're passing in the miles per hour and expected kilometers per hour within it. We're going to add a new object array. We're going to represent 100 miles per hour. We expect that to be 100 times 1.6093 to get the expected kilometers per hour. We can also do the same with another value, so we can change it to 50 miles per hour. We expect that to be 50 times 1.6093 to get the kilometers per hour. Now to add this to this unit test, we've already marked it with the theory attribute. We can call MemberData, and then we call the name of expression, and then we add our field name into there. We can also do the same when converting kilometers per hour to miles per hour. So we're going to copy and paste the new object arrays that we created up here. I'm going to create them in there, and we're going to test it with kilometers per hour. So we're going to change some of the values, so 200. In order to get the kilometers per hour to miles per hour, we need to divide it by 1.6093. We also need to mark that as a decimal. We can also do the same with 150. So it's 150 divided by 1.6093 m. And then we just need to call the MemberData within this unit test here, call the name of, and copy the field name. We've got 4 tests ready to run, with each test coming from the fields where we're supplying the data. When we run the tests, they all pass. You can try these theory examples when you download the code example at roundthecode.com/examples. There's also a link for it in the YouTube video description. The other option is to use ClassData, where you supply the data from a class. We're going to add the data for when converting miles per hour to kilometers per hour from this unit test into this class up here. This class implements an IEnumerable with an object array. We're going to supply the data for our unit tests in this private read-only field. So we're going to create a new object array, and we're going to supply 100 miles per hour, so that's this parameter, and the expected kilometers per hour will be 100 times 1.6093. And we can add another test. We can test it with 50 miles per hour, and then we expect that to be 50 times 1.6093. So we call the getEnumerator, and that just calls the data.getEnumerator. We can then add it to our unit test. So to do that, we call the ClassData attribute, we call the type of expression, and then we get the class name. So we copy and paste the class name into there, and that's been done for us. We can also do the same when converting kilometers per hour to miles per hour. So we'll copy the object arrays from up here into this separate class, move that back there, and then we can try it with 300. To get the expected miles per hour, you need to divide it by 1.6093, and we need to say that that is a decimal by adding the m to it. We can also do the same with 200 as well, so we just change the values. And in this unit test here, we're converting kilometers per hour to miles per hour. We've already marked it with the theory attribute. We then need to add the class data attribute, we call the type of expression, and then we copy the class name into it. So the data sets have been added to these unit tests, and they've been successful. When we used MemberData and ClassData, we supplied the data as an object array, but you can use the TheoryData attribute to supply strongly typed parameters. We've got this unit test. We're getting the data by calling the MemberData attribute, and we're getting it from this field here. We can then change the return type. We change it to TheoryData, and we pass in 2 decimals as the generic types. These decimals represent the parameters that we've got in our unit test. We also need to create a new instance of that, and we can remove the new object arrays because we're not using them anymore. We can also do the same when we're converting kilometers per hour to miles per hour. So we're going to add it to this unit test as well. We're going to change the return type to TheoryData with 2 decimals in the generic types, create a new instance of it, and then remove the new object array instances. And with that change, the tests still pass. To use TheoryData in a class, we change this implementation and we change it to TheoryData, and we pass in 2 generic decimal types. These of course represent the parameters that are in our unit test. We no longer need this code. We create a constructor for this class, and that's where we'll supply our test data. We call the add method, and we want to test 100 to kilometers per hour. So we put in the calculation like that. We can also do the same for 200 as well. And as a result, we no longer need that field. We can do the same when converting kilometers per hour to miles per hour. Change this to TheoryData, passing in 2 generic decimal types. No longer need this code. And we'll create a constructor for the class, and we'll add our test data. We're going to test it with 300, so expected miles per hour will be 300 divided by 1.6093, converting that number to a decimal. We can also do the same with 200 as well. And we have successful tests. So that's how you make full use of xUnit's capabilities. And did you know that xUnit has over 30 assert methods? And if you want to know what they are, watch this video next. To download the code example for this tutorial, go to roundthecode.com/examples. There's also a link for it in the YouTube video description. Leave any comments that you have about the theory attributes, and I'll see you on the next video.